on this question. They've got a deck of cards up here, and it says, as shown above, a classic deck of cards is made of 52 cards. 26 are black, right? Half of them are black up here. 26 are red, these 26. Each color is split into 2 suits of 13 cards each, clubs and spades, black cards. So these are all, yeah, whatever. Here's the game. You are playing a game where you draw a card from a standard deck, and you will win $8 if you draw a face card, the 12 cards that have faces on them, $20 if you draw an ace, and lose $7 if you draw any other card. What is the expected gain from this game? Okay, well, we're going to go to the notes. So right here, the exam 2 notes, and it's clearly gambling or insurance. Now, is there a cost or no cost? Well, there's no cost to this game, no cost. Like they never say it's $5 to play this game or something like that. You might say, well, right here it says you lose $7. Well, yeah, but that's what'll happen if you draw any other card, but it's not what you pay to play the game, right? That's different. So they'll on a question with a cost, they'll say the cost to play this game is, there's no cost here. There's no cost. So we're looking at this section. If the problem says expected value for you, that's us. No cost stated, no cost stated, and it's expected value to you, right? Because they're saying if you draw, what's expected value? It's for you, the expected value for you. So yeah, so in the notes, this is where we're at. No cost, expected value for you. So what are we supposed to do? Add up each dollar winning positive or losing negative multiplied by the probability of each. So we got to find each dollar amount, positive or negative, and multiply it by the probability and then add those up. Okay, so let's list out the different things that can happen. So the dollars possible. What can actually happen when we play this game? Well, it says right here, you can win $8. What do you got to do that? If you draw a face card. So if you get a face card, you're gonna go positive $8. And you get $20 if you draw an ace. Plus $20 if you get an ace. And then you'll lose $7, so that's an A7, if you draw any other card. Any other card you're going to lose, that's -7. So you see how I've made the wins positive and the lose negative. That's what it told me to do in the notes, right? Winning is positive, losing is negative. And I got to multiply each of those by the probability of each. So I got to go over here and say, okay, now what's the probability of each of these things happening? So for example, what's here, I can do like 3 separate lines here, might be helpful. So so first off, what is the probability of getting a face card? Well, it's all the face cards are all these. There's 12 of them, huh? 3 times 4 is 12. That's what it says right here, the 12 cards that have faces on them. So those 12 cards, how many cards in the deck? 52. So the chance that you're going to get one of those face cards is 12 out of 52, and we're supposed to multiply that, right? Next, getting an ace. What's the chance of getting an ace? Well, here's the aces. There's 4 of those. So that's 4 out of 52. That's the probability. And we're going to multiply that. That's the probability. That's the likelihood that when we reach in the deck and grab a card, we're going to get an ace. 4 of the cards out of 52 are aces. 12 of the cards out of 52 are face cards. So that's probability of getting a face card multiplied by the $8 you'll win if you get a face card. Chance of getting an ace is 4 out of 52 multiplied by the $20 you'll gain if you do that. Let me circle the face cards here. Okay. Then the last condition is any other card. Well, what's the probability we're going to get any other card? It's going to need to go right here. Well, that's all the rest of the cards. Well, how many cards is that? Well, all of these cards, if you add them up, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 times 9, 36 other cards, huh? 36 other cards out of 52. And we're going to need to multiply that. Makes sense how I'm coming up with that? So I took each money amount mentioned, right? You can win $8 if you get a face card times the chance of that, 12 out of 52, the probability, because there's 12 out of 52 cards are face cards. You win $20 if you get an ace times the probability of that, 4 out of 52. If you get any other card, you lose $7. That's -7 times the probability of getting any other card. Well, that's 36 other cards. The other way I could have done that is I could have taken 52, subtracted the 4 aces and subtracted the 12 face cards, and that would have left me with 36. That's the same answer. 30, the chance of getting any other card is 36 out of 52, because 36 of the other 52 of the 52 cards are other cards. And you lose $7, that's -7. So now we just need to figure out what that comes out to be. How do we do it? Notice what it said here. Add up each of those dollar amounts multiplied by the probability. So you're going to add those up. So I'll literally just put a big plus sign here. Add those up and see what you get. So literally on the calculator, here's what I'm going to hit. The calculator, I'm going to take the first one, 8, and I'm going to go times 12 divided by 52 plus, right, 20 times 4 divided by 52 minus 7 times 36 divided by 52. I'm running out of room here, and then hit enter. I will do that right now. And I'm getting following answer. Oops, scribbly there. Just did it on my calculator. I got minus 1.461. Probably wants us to round to the nearest penny. So I'll just cut off that 1. This is money. So minus 1.46. So there's the answer. I'll put that in right here. Minus 1.46. What that means is that's the average that we expect to happen when we play this game. If this game was a game at the casino, and they said, here's the deal, draw one card out of the deck. If you get a face card, we'll pay you $8. You get an ace, we'll pay you 20. You get any other card, you lose $7. Well, on average, you're going to lose negative, right? $1.46 every time you play the game. You're not going to lose $1.46 on any one turn. That's the average of what's going to happen if you play it again and again and again and again. That's what an expected value is. It's what you expect to happen on average. It's what the casinos calculate so that they know they're going to win in the long run on average. Sure, some people will win for a little while, get some aces and some face cards, but on average, every time a person plays this game, they're going to lose on average $1.46. So that's called the expected value. And so there we go. Now, remember, you might say, where was the adding? Well, when you add, here was the adding, and then you add a negative, it's subtraction. If any of these, if that 8 in the front was a -8, then I would have needed to put that in with a negative like this, right? Remember, that's how you do negatives. If we didn't have a -8, but if you happen to have a negative number, now you might say, well, yeah, but with the -7, well, I just subtracted because it was between two numbers. See, this is a subtraction on the TI calculator, which is which is on the right side of the calculator, add, subtract, multiply, divide. That's between two numbers, right? A subtraction is between two numbers. See how that's between two numbers there. Whereas if you need to put a negative, then that's just on one number. A negative sign is what goes on just one number. If I needed to put a negative on that 8, then it wouldn't be between two numbers. Then you got to use the negative that's in the parentheses at the very bottom of the TI calculator, right down by the enter button. So just in case you ever need that on yours. And so there we go. Oh, I'm so